Hi there, my name is Charles Bison. I'm a financial engineering student at HSM. So what is it? Well, it is the whole goal of solving a finance problem by using mathematical models. So we're going to talk about the Black-Scholes-Merton model. So first we're going to talk about what is a derivative. A derivative is a financial product that is based on the intrinsic value of and or many underlying assets where a contract is engaged between two or more parties. So derivatives can take many forms of underlying assets such as commodities, stocks, bonds, and such. Options are a derivative where the buyer has the right to buy or sell, depending on his or her position, the underlying asset at a fixed price and a fixed maturity. So the whole goal of Black and Scholes is to calculate the prices of options. So the Black and Scholes model is based on the Kaplan model of Markowitz. So it's simply a linear regression between the expected return of an asset and its systematic risk, which means that it is the risk of an entire market. So what is the Black and Scholes model? Well, it is simply using what we call the binomial model, which is another model to calculate an options price. Whereas it is simply the steady state of the binomial model, since it is a stochastic process where we're looking at time steps. So what are the parameters that can influence options? Where here's a list, and here's how it can influence the pricing of such options and how we can execute those options. So there are many other assumptions to the Black-Scholes-Merton model, and one of the things that is very important to financial engineering is what we call implied volatility. So it is simply a theoretical value that tells us what is the expected future price of a stock or an asset. Okay, how does it look? So options can take two forms. It can be either calls or puts. Calls being the right to buy the underlying asset at a fixed price, whereas a put is the right to sell the underlying asset at a fixed price. And we're only talking about European options, which have no dividends. So it can only be exercised at maturity. The whole premise of my code is based on the fact that we are in a long position. Here the user needs to R-code the basic information that he or she needs to output results. And here's our main. The main has the goal of catching errors and checking if the data inputted in basis matches real market data. This part of my code has the goal of to retrieve all the final necessary parameters to calculate the model. And here's the sauce. So my sauce is based on all the formulas that we've seen previously for Greeks and also for the Black and Scholes model for pricing options. And output, well, it's simple. We get a simple basic table that tells us everything we need to know to make a trading decision. Regarding my unit test, it's pretty simple. All of my functions have the same basic thing as you see here. And the only type of errors I can think of a rational person can make are the type error and the zero division error. And that's how we would look like if we had dividends in our model. So thank you very much for watching. I hope you enjoy yourself and have a good day.